So now we're looking at stem plots and time series. And there's a video with the notes about how to make stem plots. Problem 1, the population of the U.S. is aging, though less rapidly than other developed countries. Below is a stem plot of the percentages of residents age 65 and older in each of the 50 states, according to the 2010 consensus. There are 3 outliers. Alaska has the lowest percentage of older residents. Utah has the second lowest, and Florida has the highest. So Utah has the second lowest. So what is the percentage for Utah? Second lowest looks like it's 90%. So that would be 77. We have nobody in the 80s. We have a 90, 7.7%. None in the 8s, 9.0%. So I got to go switch it to this one. That was tricky. What tipped me off, I was like, wait, I can't have more than 100%. And how could I have figured that out? If I look at the key. The key says 7/7 represents a state with 7.7%. Always look at the key. So let's go ahead and hit submit. So a lot of times it's like I said, you would think it was 90, but you have to pay attention to the key. Here are the resting heart rates of the 26 students on the cross-country team. Which of the following is a correct set of leaves to complete the stem plot? So I'm looking for the 60s. So you can see I have a 61 here. So let me go ahead and... now, personally, if I were taking my quiz, I would just stick this data into Stemplots. So let me go ahead, first show you in the Cami. So we're on B3. We'll just B3 reflections. We can probably fit it in here. So B3 reflections. And we have more than one question for this anyways. All right. So that's what we're looking at right now. If I'm just looking at the 60s, here they are. That one, that one, that one. Oh, there we go. There's 2 66s. So the lowest one is we have a 1, 2, 3, 4, 5, 6, 6 is what I'm seeing. So let's go look. There it is, right there. Oh wait, was there a 60? No, that should be it. There must have been a 60 in there. Let me go look. Was there a 60? There's the 60. I missed the 60. There we go. And go back to the problem, hit submit, and then I'll show you a quick way to do it, especially since you have the data there. So when you have the data here, see how you can kind of copy it? Control C. Then I'm going to pull up the Stemplots, our buddy Stemplots. We love Stemplots. And it's quantitative. Those were numbers I copied. I'm going to push it in here. We won't bother with the title today. And you can actually click Stemplot, and boom, there's your stem that you were missing. So that's a nice, fast way to do it. Okay, let's see. Next question. Below is a time series plot of the number of earthquakes each year. Which of the following statements is true? The highest number of quakes was in 1965. That actually looks pretty low. The number of quakes decreased from 1920 to 1925. No, they went up. The lowest number of quakes is in 1945. It's actually over here. From 1975 to 1980, quakes decreased. I could agree with that one. Let's go see if I'm right. I don't know the answer. Well, I think I know the answer. And I do. All right, let's practice our surveying. You poll the students in a classroom and have them check off the states they have visited. Which of the following displays could be used to compare the percentage of people who have been to each state? It's tempted to, first of all, histogram is quantitative. This is categorical. So you might be tempted to say a bar graph and a circle graph. But the thing is, each person, some people will say only Texas, all right? Or, well, you live in Texas, maybe we don't count it. But some people have been to other states. Maybe you went to Oklahoma, maybe you went to Louisiana, maybe you went to California, who knows? So you can't use a circle graph, but you can use a bar graph. Okay? I'm going to go ahead and just answer the rest of these. Poll the students in a classroom and have them check off the state they were born in. Which of the following displays could be used to compare the percentages of people that were born in each state? So now, you're only born in one state, all right, unless you're somehow magically born on the borderline dividing the two. So we are allowed to use a circle graph, and we are allowed to use a bar graph, all right? So let me go ahead and submit that just so you can see both of those are working. Boom. All right. You poll the students in the classroom and have them write down their GPA. So we're doing quantitative variables. Which of the following displays could be used to compare the percentages of different GPAs? A histogram. It's the only quantitative variable. A public opinion poll in Ohio wants to determine if registered voters in the state approve of a measure banning smoking in all public areas. They use a random number table to select a sample of 50 registered voters. That's always this, if they use a random number table, and that's pretty much it. It's a simple random. A marine biologist wants to estimate the mean size of the barnacle. He randomly selected 20 10 by 10 plots and measured the size of each barnacle in each plot. So he's selecting clusters, little areas on the ground. The forest ranger, pretend it says ranger, wants to check for a pest infestation. He checks all the trees within 25 feet of his ranger station. That sounds pretty lazy to me. We call that a convenience sample. Submit answer. And that is, we got all of them correct. So you can tell me, Mrs. Overman, well, you can tell me 3 things you learned, or you can tell me 1 thing you struggle with. Maybe my explanation wasn't so great on one of these. Enjoy. Whoops, I don't need to submit answer. I need to stop recording. And don't forget to submit an answer here, I notice.